Hello, quick video on quadratic modelling. This was sent to me by Pfizer. They like these kind of questions now, don't they, Pfizer? They keep setting these quadratic modelling ones, and they're not that bad actually once you get used to them. But I understand our textbook is lame for practicing this. It just hasn't got an exercise on it. And if you know, like any maths, you need to practice things. Well, I suppose I'm going to start off by saying, well, I can see some of the coordinates here, so I can see it's supposed to be going through 4. But I can also see that it's supposed to be going through the point 50, 24 over here, and if you like, minus 50, positive 24 here. Yeah. So I've got 3 points which it's supposed to lie on. So I suppose one way I might explain this is like all quadratics can be written as y equals ax squared plus bx plus c. To be honest, this isn't the easiest way to do it. The easiest way is to think, well, all quadratics can be written in the form ax minus b squared plus c, yeah, plus b plus c. You can use either of these forms, you really can, but this one is probably a little bit easier when you know the minimum point. And often in these questions they tell you the minimum point because completed square form gives you immediately the minimum point. So if I use the second one, well, I know the minimums are going to be occurring at 0, at 0, 4, and so by inspection b equals 0, and when you can, so in other words it's of this form, y equals ax squared plus c. That just makes sure it's symmetrical about the y-axis, which I believe it does certainly imply there in the question, symmetric quadratic curve to model this cable. Yeah. So I know straight away it's of that form. Now I've got, oh, and by the way, I also know straight away by inspection. I'm just going to say by inspection because it just, when I say by inspection, I mean it's just kind of obvious. C equals 4. The one thing which might not work though, if you just assumed it was a curve y equals x squared minus 4, you're going to find that doesn't lie on your curve. So, okay, so now we've got y equals ax squared plus 4. And what we can do now is we can just say, okay, plug in 50 and plug in y is 50, sorry, y is 24 when x is 50. So I'm going to have a times 50 squared plus 4. So 20 equals 2,500a. So I guess a is quite a small number. It's 20 over 2,500, which is 2 over 250, which is 1 over 125. And so the final equation should be x squared. Sorry, it's not so neat. Let me move it down so you can see it. Y equals x squared over 125 plus 4. Yeah. Now it should be going through the point. Can I point out though, like, let's say you didn't realise that completed square form was a way to do it and you used this equation, you can still work it out because you know when x is 0, y is 4, that immediately gives you c is 4, you've got 4 equals c, yeah, so we now know it's the form y equals ax squared plus bx plus 4, yeah, oh, but we also know when y is 24, x is 50, that's going to give you 2,500a plus 50b. But you can always use the fact that, like, I see what you mean. Actually, yeah, you're going to come unstuck if you use that, aren't you? I've just seen why. Because you're going to square the minus 50, and you're going to have exactly the same value, and you're sitting there wondering, well, how can I do this? Like, yeah, I guess the other thing you can also use here is you've basically got to use this fact that the completed square form gives you the minimum vertex. I suppose what we could have done here, here's another way of doing it, you could have thought, well, the turning point is at x equals 0, so dy by dx is 2ax plus b. Yeah, this is another alternative possibility. The turning point occurs when x equals 0, and so we get 0 equals 2a times 0 plus b, and so b must equal 0. Good, there we go. And so when you find out b equals 0, you can then, sorry, I messed up plus 4 in the end, didn't I? When you find out b equals 0, you can then find a by plugging this into here and rearranging it to find a. So you're going to get exactly the same values. A is 1 over 125. I hope that makes sense anyway for that first part of the question. I suspect that's just the first bit which is doing your head in. Remember, there's two general ways of expressing a quadratic, like you've got y equals mx plus c and ax plus by equals c. Well, completed square form is really, really handy, or just differentiate and set it equal to 0. That's also works. For a moment I was going to come completely unstuck. Okay, so there we go, two different ways of doing that. Okay, Lee can safely inspect the cable up to a height of 12 meters above the walkway. The defect is reported on a cable at a location 19 meters horizontally from one of the towers. So X is 19. Sorry about the yawning. A bit tired. So X equals 19. I'm just going to plug 19 into here. I'm going to get Y equals 19 squared over 125 plus 4. I'm going to use my calculator for that. It's 361 over 125 plus 4, but let's just see what that is. I'm presuming they're going to make it close. Doesn't sound that close. Yeah, oh sorry, from one of the towers. It said this in bold, and often I ignore 19 meters from one of the towers. I'm guessing these are the towers. Let's read it carefully. Yeah, these are the towers, you know, so if it's 19 from there, I knew because my answer was too far out, and they always make it close. This is 50, this is 19, so it's actually going to be X equals 31. Oh, silly nickels. Okay, so X equals 31. Don't rush these things. If they put something in bold as well, they're saying, alert, alert, this will catch out most people. Okay, 31 squared is 961, divided by 125, plus 4. Okay, I'm now getting 11.688 meters. Yeah. Okay, so, yeah. Get up there, Lee. Get up there, Lee. You'll be fine. And stop complaining. Don't write this in the exam. I reckon you'll only break 2 legs and an arm if you fall from that height. Carefully. No, it's quite dangerous actually falling from 12 meters high. Give a reason why this model may not be suitable to determine whether Lee can safely inspect this defect. How about I say, well, what about high winds? What about high winds? They don't mind this kind of stuff. I'll have a look in a second because I have got you know, could be a very windy day, and he's very close to 12 meters. Could be a windy day, a very windy day, and he's very close to 12 meters. Yeah, please don't write get up there, Lee, and stop complaining. You should write it looks like you can just about safely inspect this defect, but you know, let's have a laugh sometimes. What do they say in part C? The thickness diameter of the cable has not been considered. Weather conditions, yeah, thought so. Walkway may not be completely horizontal. They just want you to talk about how realistic the model is. Yeah, and you know, think about real life situations, which may mean that the mathematical model shouldn't be taken too seriously. You know, maths isn't perfect when we're using it to model things. Okay, hope that was useful, Pfizer, and anybody else watching. Keep up the good work for the first exam. You can do it. Bye bye.